Hi, what is the value of x given that you have 8 to the power of x plus 2 to the power of x equals 150? Then let's have it to be solution. Then from here, let's have this 8 in base 2 as 2 to the power of 3, then all in bracket to the power of x plus 2 to the power of x equals 150. Remember, when you have a to the power of m all in bracket to the power of n, we can interchange this power from the law of indices as a to the power of n, again, all in bracket to the power of m. By applying it to this, we are going to have 2 to the power of x all in bracket to the power of 3 plus 2 to the power of x equals 150. So far we have 2 to the power of x in common. Let's have it to be y, that is 2 to the power of x to be equals y. Then from here we have y to the power of 3 plus y will be equals 150. But remember that when you have 26y minus 25y will be give you back your y. This. Then let's substitute this expression here. So we are going to have here to be y to the power of 3 minus 25y plus 26y equals 150. This expression is the same thing as this. Then from here we have y to the power of 3 minus 25y. Let's pick it. Let's group this and this together. Plus, let's open the bracket as 26y. Taking this one to here, along with this will be minus 150. Then we should set everything to be equals 0. Then from here we have y in common, so we can factor it out as y. This y to the power of 3 divided by this y, we have only y to the power of 2. Minus 25y divided by y, we have only minus 25 as this. Plus, let us factor 26. Outside of this, we have here to be 26. Open the bracket. 26y divided by 26, we are going to be left with only y. Then 150 divided by 26, we are going to have only 5. Then we have minus. We close it, we set everything to be equal 0. Then when we have this as y, open bracket, y to the power of 2 minus, let's have 25 in base 5 as 5 to the power of 2 as this, plus 26 into y minus 5, we close the bracket as this. We call this difference of 2 square. When you have a to the power of 2 minus b to the power of 2, you have it as a plus b as this, again multiplied by a minus b as this. Then, by applying it here, we are going to have, we have y outside. Here will be y plus 5, all in brackets as this, again multiplied by y minus 5. Remember, we have plus 26 into y minus 5. Then we set everything to be equal 0. Then you can see that we have y minus 5 in common. So when we factor it out, we are going to have here to be y minus 5 as this. Then the whole of everything here divided by y minus 5 in parentheses, we are going to have only y into y plus 5. The whole of everything here divided by y minus 5 in parentheses, we have only 26 left. Then we close it, we set everything to be equal 0. Now, we have here to be y minus 5 as this. Then open the bracket, we are going to have here to be y squared. Y times this, we have it to be 5y. Then we have here to be plus 26. We close it, then we set everything to be equal 0. Then what are we trying to say here is that for this particular expression at the left hand side to be equals 0 that we have at the right hand side, either of this expression must be equal to 0. It's either we have y minus 5 in parentheses equal to 0, or we have y squared plus 5y plus 26 in parentheses to be equals 0. Then let's see. Then from here, let's say we have it to be case 1. For case 1, that is, we are going to have y minus 5 to be equal 0. Then for case 2, we are going to have y squared plus 5y plus 26 to be equal 0. Then for case 1, it implies we have our y to be equals 5. Then, but remember, we have y to be equals 2 to the power of x. So from here, we have 2 to the power of x equals 5. By introducing log, we are going to have log 2 to the power of x. But let us have this log to be in base 2. As this, we have log 5 to be in base 2. Look at this. This power will come down to the base as x multiplied by log 2 in base 2 will be equals log 5 in base 2. Now, this log 2 in base 2 will be 1, so we have our x to be equals log 5 in base 2. So finally, we can declare that we have the first degree solution to be log 5 in base 2 as this. So now let's go along with case 2. Case 2 says y squared plus 5y equals plus 26 equals 0. But before that, let us test for discriminant d equals b squared minus 4ac. The reason why I want to test is that are we going to have a real solution as this or a complex solution? And we don't want a complex solution, we want a real solution. Then from here, we have d will be equals, our b is the coefficient of y, which is 5. We have here to be 5 to the power of 2. Then we have minus 4a is the coefficient of y squared, which is 1. C is the coefficient, is the constant of the expression, 26. Then from here, we have our d to be equals 25 minus 4 times 26. We have it to be 104. Then we have our d to be equals 25 minus 104. We have here to be minus 79. Now we have here to be negative. This implies that our d equals minus 79, which is less than 0. So since d equals negative, that is less than 0, so this implies that we have no real solution. And so therefore, we don't want this. We reject y squared plus 5y plus 26 to be equal 0. We reject this expression. So we only consider this. So therefore, given the problem 8 to the power of x plus 2 to the power of x equals 150. So the real solution for the problem is x equals log 5 in log 5 in base 2. And if you want to check, we can check. You know, we have 2 to the power of 3 as 8, then again to the power of x plus 2 to the power of x, then equals 150. Now, from here, you see we can have here to be 2 to the power of 3. Then our x equals log of 5 in base 2. So here will be log 5 in base 2. You can see. So plus 2 to the power of log 5 in base 2. Then this is going to give us 150. Now let's see what will happen. So from here, you see we can have this as 2 to the power of this as 3 log 5 in base 2 plus 2 to the power of log 5 in base 2. Then it's going to give us 150. Let's take this base back to the power as here. Then will be 2 to the power of log 5 to the power of 3 in base 2 plus 2 to the power of log 5 in base 2. Then it's going to give us 150. Then we have here to be 2 to the power of log 5 to the power of 3 is 125. Then in base 2 plus 2 to the power of log 5 in base 2. Then it's going to give us 150. Now, there's one from the law of logarithm. When you have a to the power of log b to the base of a, so far they have the same base as this, the output will be equals b, this b. Now, I'm looking at this expression, they have the same base as this 2, 2. 22. The output will be 25. 125 plus the output of this one will also be 5, which equals 150. 125 plus 5 will give us 150, which equals 150. So therefore, S equals log 5 in base 2 is the correct answer for the problem. If you are new and you find this video interesting, don't forget to share, like, comments, and subscribe to our YouTube channel for more maths tutorial videos. Bye bye.